be able to know the 5-number summary quickly and easily is always least to greatest. Laura, 1,000 points right there. And let's do this.
I found him. What's he doing? I don't know.
The 5-number summary is the following values.
He's talking to someone.
From least to greatest, min, Q1, median, Q3, and the max. Nice answers. If you put the 5-number summary in the chat, you get 1,000 points. Keep these answers coming.
What is it? What happened?
Hey everyone, how are we doing? A little Stranger Things to start the day. We got some good questions here. We've got some 201 and we got some 474. For 474, right, Shamila, right there? 474, I believe. Let me know if I'm wrong. Computer's being weird. I should have shut it down. Should have restarted. Yep, 474. Is it that question about presidents? Was it, Julia? Stat 201, chapter 3. Question 2. Awesome. Okay, we'll do that here in a second. BAS 474. Homework 2. Question 2. Let me get it started up right here. Thank you, everyone, for being here. Let's throw out 100 points. Sorry, Mubot just woke up. I didn't just wake up, but Mubot did. I got my coffee. Almost done with it. About to need that second cup of coffee. Coffee. I am addicted to coffee. I think we have to admit things to ourselves like that. Like if I don't get my coffee in the morning, whoo, I don't feel awake. Gotta wake up, get that coffee, and then you're awake. It's a second wake up. It's interesting. Life before coffee. In college, you too, Angel? Yeah. Shamila says me too. In college, I really didn't drink coffee that much. It's interesting. Maybe it's just back in my day, we didn't have Starbucks at every corner. I mean, we did. Oh no, Starbucks every corner started around 05, 06. So I think by the time I was back in graduate school, Starbucks was everywhere. There was like 3 Starbucks on campus. So it's funny. Shrek 2, I think, makes the joke about Starbucks. Like they run out of one Starbucks into another Starbucks. I'm getting the assignment open as we speak. So whenever Shrek 2 came out, let me Google that. Shrek. So I say 05. 04. Shrek 2 was 04. So Starbucks have been on every corner. Go to Starbucks order. Oh man, I'm a pumpkin spice angel. I'm all about that PSL. Just get me a venti PSL, and then I'll probably split it up into 2 days. Good to see you here, Jarius. Let's throw out some more points right here for everybody. I'll probably get that pumpkin spice, split it over 2 days, maybe mix it in with my coffee, try to get some extra life out of it. But oh my gosh, I'm sorting things. What's your go-to? What is your go-to for everyone in the chat right now? What is your go-to Starbucks offer order? I like some Einstein's too. And Deborah, who works at Einstein's, absolutely stellar. If you know Deborah, who works at Einstein's, tell her I say hey. I got to see her when I came back to campus. She is so awesome. I think she's working at Einstein's at the Mossman building right now. So that area. I'm about to take the campus content quiz, chapter 1, 2. Should I expect? We could do that here in a moment if you want. Victoria, it's over those homework. It's over like the lectures a little bit more. I'll put that on the list. Canvas content quiz 1 and 2, or Canvas content quiz 1, right? It's quiz 1, right? Do that here in a little bit. Coffee and cream basic right there. Caramel frappuccino, iced mocha latte with soy milk and brown sugar. Ooh, Angel, that sounds really good. That sounds really good there. Iced matcha. Is that it's like that green thing, right? You know what it is? The brown sugar and syrup sounds really good. I would try that. One. I'd try all those right there. I mean, I'm coffee and cream. The green stuff. Yeah, the green stuff. I can see the picture of it. Here we go. Let's start the first question. Let's do this. Thank you so much, everyone, for being here. I did move my camera. 2 seconds. Brian has bumped his camera, and thus he has to move himself over to the side a little bit more so he's not as much on the screen. Okay, that's the Brian moving Brian's screen sound right there. Okay, so this is currently at the 7-minute 45 mark. And here we go. So a research group of 2,115 U.S. adults and 1,000. Now, what they're giving you right here is they're actually giving you the row totals. So they're actually giving you the totals for over here. So they're being super nice in that instance. Oh my gosh, I'm gonna click every button. So these values right here are the row totals for US adults. That's gonna go right here. And this is the row totals for college presidents. To rate their job value for the money spent by students and families as good, excellent, only, and fair, and all those other categories. So we know the totals right here. So the first thing it asks is what is the conditional distribution percent of college presidents on their opinion? Now, to do conditional, that means we're setting a condition. What is this first number going to be here? So this is for only presidents. What do they view as poor? So who can tell me the mathematics here? Only the first number. I'm just asking the very first number right here. Just tell me the mathematics and how we would get it. And what does a conditional distribution mean? It means you're setting a condition where you're saying like only this group. Now you're looking at, and so I'll phrase it this way. For only college presidents, what percent rate their performance as poor? For only college presidents. So think about the mathematics you'd have to use to solve to get those numbers. You can just type them in the chat for 100 points. So great job, Julia. That's gonna be it, right? I think so, right? So Julia, you're getting it. That's awesome. Let's see here. Let's make sure. Watch me get it wrong. Dun dun dun. Because conditional means setting a condition. So we should, and tell me if you get a number, a decimal error. It's going to be that right there, 1 decimal. So we're just rounding to 1 decimal right there. Next is fair. So it's going to be the same thing. If you'll want to check my mathematics, 21 right there, rounds to 21. Next is 627 divided by. Once you start coding, you want to do everything in code. You want to be like, I can do this faster in code. Let me code this. I can just take that vector and divide by the total. Oh, and then the last one's going to be 0. 1075, 17.6. So we're just rounding. If you're wondering what we're doing, we're just taking this and moving the decimal over. So it's technically 17.58, but that rounds to 17.6. And that should do it. I thought there's 2 parts to this, right? What is the conditional distribution percent of college professors' opinions? Woo! And then this part. Find the conditional distribution. Find the conditional distribution of opinions of U.S. adults when the categories are combined into negative, okay, poor, which middle only, and positive, good or excellent. Okay. So good or excellent. This is a very interesting question. So they're doing poor, only fair, and then they're taking away this right here. Okay, so wow. And this is for only U.S. adults. This is interesting. This is the one you're talking about, right, Julia? This is a bit of a mean question, I'd say, because what they're asking you to do right here is they want you to get a new total amount. They're going to remove this one, and then they're going to combine these together into groups. So the numbers are going to be, so we have to subtract from 215 minus 62. That's the new total. Does that make sense? The reason I'm doing it is this value right here. They're not including. I don't see them combining that anywhere. And the do not know does not apply. NA means does not apply. DK, I think, does not know. They should really explain that. And so they're taking this and they're just removing it from the equation. That's being removed. Hence why over here we're subtracting it off. So this is going to give us a new grand total. We're going to double check our mathematics, make sure we don't make an error, because if I do the math in my head, which I can do, sometimes you make an error. 2053 is the new grand total. So all these numbers right here are going to be justly divided by 2053. So everything is divided by 2053. And the last one right here is going to be the combination of 746 plus 101. That's 847. That should do it right there. And now we just double check our math. So let's put these numbers in the chat right here. Good to see you here, Meredith. And let us know, Kenneth, let us know if you have questions. 316 divided by 2053, 15.4. It's U.S. adults, right? U.S. adults. So it's only U.S. adults. That's a key thing to note right there. It's only U.S. adults. 890 divided by 2053 is 43.4. And then last but not least, we have here, just making sure, got to make sure we tune the numbers right. 847 divided by 2053. Now, a good check to make sure you've done this right is after you complete something like this, you can always take the numbers right there on the bottom and add them up, and they should add up to 100, but sometimes due to rounding, you'll get a little bit more. So there's that. And, 15.4. Let's rewind this. 15.4 plus 43.4 plus 41.3. Okay. Should be right. Sometimes rounding can do this. One of the questions even mentions this. Woo! Woo! Scary question. Does that make more sense, Julie, right there? That's a little bit tricky because they want you to subtract off. They're not using that group anymore. The does not know, did not answer group right there, which I really wish they told you what that meant right there. I know what NA means. Capital NA means does not apply. We use that a lot in coding in R. You're welcome, Julie. 100 points. Thank you for asking. Good question right there. Sometimes it just makes more sense to walk through these things. I think I was looking at question A when I was talking to you on Discord. Sorry about that. Follow up and be like, no, I'm talking about question B, the one that says remove the groups. The confusing one. Because even I was looking at that. I'm like, that's a little bit weird right there. Well, great job. One question down. We got another one coming up right here. We got some 474. Let's do some 474. And so good to see everyone. Just drop those questions in the chat. If you have a question, let us know. Even if I'm working on one right now, you can always just say, hey, Brian, I'm working on this. Thank you, John. What's up with those goats right there? So we just love people being here, swinging by, asking questions. But whatever you're working on, just be like, hey, I'm working on this. As we'll be doing Canvas content number 1 after this. Thank you to the individual who said that. What's up, Shamila? It's time for some 474. Here we go. Let's check out some 474. Right, question number 2, right? The while loop, right? Which is paying off the car loan. Let's go check it out here. Wrong button. Hey, Lashia, good to see you here. Let us know whatever questions you have. Drop them in the chat. Okay, we are working on some 474. Question number 2, while loops. So no, the for loop as well. What part are you wondering about? What are you wondering about specifically? But let me know and we'll talk about that, because I'm not going to work the exact, because I don't want to solve the loops for everybody, but I don't want to create what we're trying to create, because I know you're posting on Discord about it. Let me say I got Discord over here. For example, I think you were asking about, should I add this to the calculations and then store it to the output vector? I think so. What to loop on? So usually with these things, we're looping on like a time thing. Like, think about trying to not do the exact problem. So if we're thinking about what to loop on or what to go for, we're trying to loop I think I could do it. If you imagine every hour. So if we were to go here to hour, and we were to put here hour at 0. And every hour you get $1. So if I were to put here money, and your money starts at 0. This is kind of constructing with the placeholder number. Ah, cool. For number 2, I'll look at that, John. You got it. And so this kind of goes towards for loops and while loops, John. They're doing a little bit more advanced work on it. We love it. So this might help. Is your money is going to become a vector. Now your money at time 1, let's say, is 0. Does that make sense right there? You have no money. It's current time 1. You have no money. You've worked 0 hours. And then every hour you work maybe is your wage. So your wage is, let's say, $12. Does this all make sense? You're going to make $12 an hour. Amount, time in the bank, and interest rate to calculate the final amount. Well, so this is, do I ask the user to enter the amount? You can set them this. I think Nana was talking about this. Dr. Brian was talking about this. Was talking about setting these outside the loop, so that way you could then adjust them without worrying about seeing them out inside the loop. Which is, we'll go towards functions this week, which will really help with the utilization of making a function, because you're basically defining arguments right here as objects. And so now, when you think about this, if you work an hour, we're going to go here to money and we'll go to money position 2, and in money position 2, we'll store what was in money position 1, and we'll go right here on, and then we'll take and add to it your wage. Does that make sense right there? So we have money, and there's many ways to do this. Like, we can go ways of doing this without a for loop, but the task this way right here is to do it with a for loop. But I want you to notice something. This takes what money we had, and then it's going to store to money position 2, which is the next element, and adds to it our wage. So now we go right here and take a look at the structure. We go to money position 3 and store what was in money position 2, and we can watch as the money vector appends as in grows. So now you notice we're getting it. And think about what this, just tell me this will store what amount. It's going to store what was in money position 3 plus wage into money position 4. So what is this line of code going to do right here? What is that line of code going to do right there? This is kind of similar-esque, but not quite your work. If you can kind of decode this and think about how this works, this is a very huge hint, like for the structure of what we're doing. I might like, because now we have kind of what we need. We can use a for loop now, exactly. And do you see, because the structure has remained identical. And that's what I'm doing right here, because now you want to go in and try to figure out what your placeholder is and what your placeholder will be, because you want to notice the things that change. Those are the things that change, and then use it as a for loop. And this will be the variable right here. Now I'm doing some, like, you'll delete, you won't use all these lines. Like if I'm going to keep this, I would hashtag it out. I don't even need this right here, but I do this to make sure it works. So I was working with one person this weekend, and I was like, okay, wait. I want you to not have a for loop right now, because they already had the for loop and things weren't working. I was like, I want you to undo it, and I want you to write the first 2 iterations of the for loop such that it stores into the elements. And then they got to work. They were like, yes. And they got to work in like 5 minutes. So they'd been working on it for, I don't know how long, but as soon as I was like, I don't want you to do a for loop, they got it. Because then they saw the structure, and then they knew what to input for the variable that then changes, and then what to loop it through. So, Shamila, what do you think? Did this help out a good bit? Let me know. I want to spend, we've only spent like a few minutes here on this, but if I can get more help, I'm trying to not do the full thing. I'm trying to like show some ideas. I mean, we've just stored like hour. You just have to think how this applies to you. Of course, this hour right here, probably that would be preferably like this is after the first hour work. So hour could be the placeholder. We could call the hour the placeholder, and it'd be like after 1 hour of work. Of course, with hours, the placeholder, that's after, yeah, that'd be right. And then this would be, no, I'm not going to say what that is. But then how would the for loop break? So let me show you. I think I can do this. So with that right there, you notice I changed the structure of it. So good to see you here, me. It's good to see you. Maybe we want to see how long it would take for us to make at least $500. So I'd go right here and I'd go to 4, and let's put in here, question 2, making and breaking for loops. We're going to call this making and breaking for loops. So if I go here to the following, I'm going to say, here's my for loop structure. The variable name is hour, like that. And then the vector is 1 through 1,000, but wait. Watch this, you ready? In the example we showed, where I take our, so it'd be like, does this make sense right here, what I've done? Because it's right here, we're storing into the next position. This is what we have at hour 1, and then this is what we have at hour 2, because it's storing into hour 2. That makes sense? Good. So now you might say, well, Brian, this loop's going to create, and we're going to reset the money vector here at the start of it. Because this is all like, this work right here is just practice work. Does that make sense? Like I wouldn't leave that in my file as code. Once I get this working and I make the loop, I'd comment that stuff out. So I'm going to go here, and if I run this, it's just going to run a loop that makes tons of money for me. But now I just want to make, can we also go over question 2 on chapter 3 quiz? Yeah, Victoria, you got it. Let me write that down here. Now I'm going to throw in a break right here. Thank you so much. Stat 201, chapter 3 quiz. Question 2, you got it. We'll go in here. Is it the rain, no rain? Ooh, is it the rain, no rain? So now watch this. If money greater than or equal to 1,000, then run code break. And then at the end of this, we could say, oh, and then I wonder if, I think once you break, you can throw a message on another way. But hey, Evan, good to see you here. We bought saying hey in the chat. Has condition O, if tail of money. I checked the whole vector of money, if tail of money. So tail money 1. Okay, so I'm checking the last element of it. And now money only goes up. Ooh. If tail of money. I should have found it. If tail of money. If tail of money is greater than or equal to this, then break. Did I not overwrite the money vector? I might not have overwritten the money vector. Ooh, what's going on, Shamila? Let's see. What did Brian do? Should work. Oh, did I misspell break? Break looks... No, break's right. Oh. What is going on? Oh, for loop's broken. I'm deleting things. I'm breaking things. Good to see you here, Corbin. Brian's breaking his code. Let me try another thing. If 2 equals 2. Loop shouldn't run. What? Loop should break. I was doing this a few days ago. 4. I should be able to break the loop. What is going on? Can you add a message right to the break? Break, I think, just works as its own thing. Break should just stop it. That would show us if it's entering the... Well, it should... If 2 equals 2, then break this loop. So break right here, they function the same way as a control statement, and that's really not helpful. Reserved word, we know what that means. It means we can't overwrite it. And right here, if condition... Right here, they're showing it, but they're not even using a break. So why are they like not even using it? What's the value of wage? Oh, wage was we still have wage stored as $12. Did I remove wage? Wage is still $12. So if we're just trying to run it so it print I, and I will just go through 1 through 10. Okay, good. It broke. You see, so it is working. Okay, let me see what's going on. So notice here that it goes into the loop, and then here it just breaks when it hits this right here. I think use something else. Else if. I don't use else if. You could. Is it working? If that's working, then do it. I'm just trying to get this torque right here. If I is equal to 8, then break. So now once it says 8, it breaks. Okay, good. So this code is perfectly working. I'm wondering what I wrote wrong right here, because hours going through that. And so we should have if hour is equal to 4, then break. And it's just going through and running everything. It looks like it's making the full loop. Oh, I know it. No, I know what it is. Who knows what it is? 1,000 points if you know what it is. The issue is it's doing what it should do. The issue is line 9. I think everything I've done is correct. The issue is line 9. The issue is line 9. Does anyone know what it is? I'll say what it is in a moment. Everything here has been correct. I know what it is. No idea what it is. Evan, I'll give you 1,000 points for just saying that. Look, if anyone says they know what it is, I'll give you 1,000 points. Now I'll give you 1,000 points if you know what it is and you say what it is. You were just listening in. I like that. The issue is line 9. The loop is working properly. It's that I didn't do what I wanted to do on line 9. So what I wanted to do was I wanted to reset the money vector. So I wanted to reset my money vector. So why is this not doing what I wanted it to do? How do I reset the money vector? So how do I reset the money vector? The loop is doing what I wanted it to do. That is working correctly. But I want to reset the money vector. So change line 9 to reset the money vector. I'm not resetting the money vector on line 9. That's the loop's doing what it should do. It's just that the money vector has not been reset. So how'd I do that? Yeah, we could do that. And then close to Miller, make sure to have the, we could just do this right here. And we want to store 0 probably. Well, I guess, should we create an empty vector? We could store 0 into it. So this will, if you watch money vector right here, it's just going to be overwritten with 0 in position 1. And now when the loop runs, the loop ends with money right over 1,000. So it was doing, I was like, why is it not breaking? It's because the loop was doing it, but it was overwriting current positions. It wasn't resetting what was in the money vector. So everything was working properly. And I was just like, this is weird. Like I've used break a whole bunch of times. Why is it not doing it? It's because I wasn't resetting money vector to 0. I was keeping all the elements in there and just overwriting the positions that I was writing to, but it was keeping all the appended positions on there. Does that make sense when I say it that way? Like I had a vector like this and I was just rewriting the start of it multiple times, but I wanted to just totally erase the vector and make a new vector of a certain length, which I've done right here. So now if I say something like, if 2 equals 2 inside of here, it's going to only run it one time, which is what I was using to check it. So now when I run this, it just runs the loop one time and appends a new thing, but then breaks when it gets to the if statement right there. So that works right there. We could add in another if. So if, and we could use the same thing right here. We just take this structure. I might try it with, I don't think break can use a message. You can go cat and say something like, you now have over $1,000. And this just prints to the screen. Cat just displays a message. So now when we run the loop, it says you now have over $1,000. Or you could even do a cat paste, which is kind of nice. And with cat paste right here, so cat paste allows you a little more functionality inside the message that is printed to the screen. So we're just going to throw a paste around here. And we're going to say, you now have, and then we're going to say, you now have tail money 1, didn't capitalize the money, tail money $1 dollars. So think about what this is going to say right here when it prints to the screen. You now have tail money $1. It's going to say you now have how many dollars? So it's going to take the what when we do tail of something. So it's going to print this to the screen at the end of the loop and say you now have, and then this is how to put in what I would say is messages in your loop. Like it's going to do this at the end of the loop. Like it's going to print this and then it's going to end the loop. So it's going to display this message to the screen and then it's going to end the loop. So you now have tail money. What is tail money? You can see the tail money. So what will this message say right here? Well, it's going to say you now have, and what does tail money $1 mean? You now have $1,008 exactly. So we run it. It says you now have $1,008 because it finds the last element of the loop. Great job right there, Shamila. Is this making more sense? And other than Brian forgetting how to code for a moment or forgetting to redo his vector, it's always the little things. You're just looking at it, you're like, it does what I want it to do. Like, I was like, there's nothing theoretically wrong about that. And I just wasn't removing my loop. I was like, I know how to do an if break. I know how to do it. I should have just cleared my global environment. But that's got it. The littlest things, when something doesn't make sense, that's when it's like, the worst thing is when you know how to code and then the code's not doing what you want. It's because another thing you have is interfering. So you're like, everything theoretically should work. I got to get a haircut. My hair is getting crazy. Yes, can we have the break statement in the first condition? We might be able to. Let's try that. So let's see right here. Do you append it? This is something I don't usually do. So he doesn't like that. Should we append it? Oh wait, I have it inside the paste. We don't want it inside the paste. You don't paste a break. Okay, it looks to work. It looks to you don't put it as another argument because you're pasting or it doesn't need it as another argument inside of here because it's not a function. It's the code you're running. So this is not a function right here. This is just a bunch of code that runs. So it'd be a new line inside of the because you're inside of this if idea right here. Like, if this is true, then run this code. So you're not going to put a comma because that's not an argument inside of a function. You're just going to do a new line. Does that make sense, Shmuel, right there? So that does it. There's your stop. There's your break. Now you got to be careful, because if you put the break here, break's going to end your loop. It's going to break your loop to start right there. So you're not going to get your message. So it matters where you put the break right there. Shamila, 100 points, great answers. Just saves one more if statement. You're right. You're right. You know what, Shamila? That's worth some 500 points. That is a really good answer right there. Really good smart coding. Why write two if statements if we're using the same if condition, right? So we want this to run if this is true. We want this to run if this is true. If it's the same if, just put them together and just append lines of code inside your if. Much smarter running right there. Doing things on the fly versus thinking them through is where we take the time to be like, I bet I could make this a little bit better. But that's what we want to do. We want to think about better ways to code it. I just throw those in there to see if you catch it. Well, excellent work. Great job. I think we're doing some Canvas content here in a moment, but keep those questions coming because we still got a lot of time. Here we go back to the main screen. Okay, everybody. Can we look at number 3 on assignment 2? My error says length 0. Is that for 320? Is that for 320? But I thought it needs the backticks, which I read as code with backtick characters and R markdown 320. Okay, number 3 on assignment 2. Let me write that down. And you can mention these anytime. The best thing to do is mention them anytime because we're starting to get a list going here. But that is assignment 2, number 3, question 3. Then make sure if you think you've broken your for loops, please contact me immediately. Or if you think you've broken your code, let me know. You can send me your files with the plus button on Discord and just send them to me on a DM or something. But let me know if you think you've broken your work. I'm struggling with the placeholder. John, I think, wants that there too. John, did we get your question written down? Did we get yours written down, John? If you mention one, let me know. We're about to do Canvas content for 201. Don't be a weird, browser. Be weird. My fantasy teams won last night. I'm so happy. My fantasy team, singular, won last night. It's interesting. The Tampa Bay looked to have a pretty good game. Oh yeah, I watch them just like by watching the scores. I have to go work. Will these off stars be posted? Oh yeah, they're recorded. I don't know if you wrote it down, but I asked like 15 minutes ago. Maybe. What is it, John? Let me advance it a little bit up. I was wondering if you replace the 4th position that has the 3 in it. For which question, Meath? Which one? Let's do a few. Okay. We're gonna do 2 versions of this. Q2. Who's your team? I guess the Buccaneers. I've got the kicker and the quarterback. So you said question 2. Wait, question 2. Did you see the Bama game? I didn't see it. How'd it go? The second question, Meath wants that one too. So let's put BS 320 assignment 2, question 2. Okay, we got that written down. We got 2 201 questions. Then we got that for BS 320. You got it. Okay, let's do the Canvas content. Here we go. Ooh, Bama almost lost to UT Texas. You got UT in your name, you're a good team. That's what I say. Bama's gonna lose. If we play Bama, they'll lose. Okay, so here we go. Stat 201 Canvas content number 1. An identifier, which is one of our 3 types of variables, is a special case categorical variable. What do you think there? What do people think? A variable is a special case categorical variable. You should have. Aren't you? Yep, I'm back in Texas. Yep. I miss Texas. Where part I'm in College Station. So we have 3 types of variables. We have quantitative, categorical, and identifier. Quantitative are actual real numbers. Identifiers are things that are unique for each and every observation. They're special. They're kind of categorical. So the thing is, they're actually special case categorical variables that are unique. So don't worry, Victoria, they're 100 points. Second best place in Texas. That'd be Paris, Texas, or Lufkin, Texas. I don't know. I've been all over. So this is true. Categorical variables are special case, identifiers are special case. Good to see you here, Taylor. Identifiers are special case categorical variables. And here's the thing. These can appear on the test. So if you have note cards right now, I would write these down on note cards. Like An identifier is a special case categorical variable. True. So I'll probably try to mention this in class today, but these are really good to study for the test because Canvas content is what your test is going to look like. So we build the test from Canvas content questions. They're not all Canvas content questions, but people always say, what's the test going to look like? If you hear someone ask that in class, what do we say? The test is going to look a lot like your what's. Now you won't have open book for the test. You won't be able to retake the test, but other than those things, the test will look a lot like the Canvas content, Evan. Yep. So Canvas content is the number one thing to know. So let's do the rest of it. All data needs what? Don't even look at those answers. All data needs what? All data needs what? All data needs what? Great job, Corbin, right there. All data needs what? All data needs what? Context. All data needs context. Great job right there, Evan. All data needs context. Like 98% of people get this question when I look over the reviews of it. And then someone puts like statistics. All data needs statistics. Well, I mean, we use statistics to describe what's going on for estimates of the truth. The type of data that represents actual real numbers, what is that? The type of data, is it quantitative, categories, or does it identify? The real numbers is quantitative. Now this one right here, remember, we do have this graphic right here, which gives you all the answers. So make sure to maybe take a screenshot of this or to practice it, put it on note cards. But there's a few easy ones to remember right here. Bar charts and pie charts can make the same thing. Like you can make a bar chart of your favorite pies or a pie chart of your favorite bars. If I ask you your favorite pie, that's a what question. Like, this is a good way just to memorize pie chart is this. If I ask you, what's your favorite pie? That's a what question. So if I ask you, what's your favorite pie? That's a what question. So we're answering what this is right here. It's categorical. What's your favorite pie is a categorical question. So that's a good way to remember what pie charts are, is they're categorical. Does kind of quantitative, it needs to be numbers. Exactly. But numbers are not always like real numbers that we can take differences of are quantitative. But just because you say group 1, group 2, group 3, and those are numbers, that doesn't mean it's quantitative. Good questions and answers, Victoria, right there. Keep up those questions/answers right there. Now, a Pareto is a special kind of what that's been put in order. A Pareto is a special kind of what that's been put in order. And make sure you have these notes. If you don't have it, we're reviewing right here. A Pareto is a special kind of bar chart. And great job, everyone. 100 points. Keep those answers coming up. So a bar chart that's been put in order, if it's a bar chart, it has to be what? If a Pareto is a bar chart, which it is, bars and pies and Paretos are all what kinds? You can see it above my head right up there. Bars and pies are all categorical. So there's another one. If we know Paretos are bar charts and bars and pies, bar chart of your favorite pie chart of your favorite bar, categorical, good stuff right there. All those cats in the chat. Now, histograms are going to be a what display? I'm trying to think of a good trick to remember histogram. I wonder why they call it histogram. I don't know. See, when I don't know the answer. It's quantitative, and then a stem and leaf is a histogram where you can see the numbers. So if we review back to the notes, histograms, the stem and leaves, are quite similar. A histogram is going to be history of grams. Is it really? Is that really it, Evan? I wonder. Histograms are a quantitative display, and stem and leaves are histograms where you can see the numbers. I know, Evan. I was like, that seems a little interesting. I like it. Evan, 100 points. Keep up the jokes. Last but not least, the median is highly influenced by outliers. Okay, I want you to keep telling me what the median is here. You ready? I'm going to tell you 3 numbers, and I want you to tell me the median. You ready? 1, 2, 5. What's the median? You have to tell me the median as I say these numbers. 1, 2, 5. So what's the median? 1, 2, 5. What's the median? 1, 2, 5. It's 2. 1, 2, 100. 1, 2, 100. It's 2. 1, 2, a billion. 1, 2, a billion. 1, 2, a trillion. 1, 2, a trillion. Now, the 2 is still the median because it's still the middle number. Ooh, Evan's got some stuff right there for us. Ooh, Evan, 100 points. So if you notice, the median is highly influenced by outliers. True or false? Very much what with that example where we kept making a bigger outlier here and we kept saying 1, 2, and then a billion. 1, 2, 100. The median is still 2. So the answer most definitely here is what for the median is highly influenced. It's definitely false. Now, what would change drastically? What measure of center would constantly be inflated as outliers impacted and it would follow the skew? What measure of center, which is not median, would be highly influenced by that and follow the skew? the mean. Great job right there, Evan. So you notice we can get some good review and some good practice, and we can think about how to think about these things theoretically to answer the questions and show that the median is not highly influenced by outliers. The mean is. The mean would be the average of all the values. So if you had something like 1, 2, and 100, it would be like 334 or something close to that. The word histogram came from the Greek histos, meaning pole or mast or gram, which means chart or graph. Hence, the direct definition of histogram is pole chart. Oh, I've heard pole chart before. Oh man, I thought it'd be chart. Like a histogram is a chart. So yeah. Gram, which means graph, and histome, which means pole. So it's like the poles. That's interesting. Cool. Well, let's do one more version of this. Okay. Ooh, we get a tricky one right here. You ready? Chart is more fun to say. I do agree. I wish it was chart. Like it's like a double meaning. The variable average chocolate rating is what kind of variable? Now, when you look at average chocolate rating, it looks a lot like what's right here. If you look at the variable and someone found out the average chocolate rating, it looks like a what variable right here. Just looking at it, 3.38, 3.25, looks like numbers. And now the thing to know if it's actually quantitative is, could you subtract the difference? Does a difference of 2 in average chocolate rating sound meaningful to you? Like, or 1, like it looks like this one is about 1 higher than this one. Like we say the average chocolate rating has a difference of 1. Is that meaningful? Like if I say this chocolate, it has a rating that is higher by 1. Does that sound meaningful to you? That the average rating for this chocolate is 1 higher than the other. So people rated the chocolate and they're like, oh, I give that one like a 4.5. So this is the rating the chocolate got. Yeah, I think so. Here, we'll check out the next. Like I could rate the chocolate at 10. I think it's out of 5 maybe, because like, you know, they're kind of low. So we asked them rate the chocolate 1 to 5. So in this instance right here, yeah, if these are out of 10, these are really bad chocolates. If they're out of 5, then they're doing okay. Like 5 is like, this is the best chocolate you've ever had. And 4 is like, it's okay. 3 is like, I don't know. You get towards 1. So the rating right here is definitely what? Q, I, or C. The rating right here is Q, I, or C. A sample is used to make an inference. I said it was true. A sample. That'd be true, Victoria. No, people are saying C. Don't worry, 100 points. People are saying C. It's quantitative. Because, take a look. Here's how to check if something's quantitative. You ready? I'm throwing out 100 points. Don't worry, this is the good practice. It is Q because, let me ask you 2 questions. You ready? This is how to check if something's quantitative. Is this a number? Is this a number? Is this a number? Yes or no? Just, is this a number? Are these numbers? That's your first check. To see if something's quantitative, is that a number? It's a number, right? So that's check number 1. And then check number 2 is, if I take a difference between these 2 chocolates, does it make sense? Like if I say company Caribbeans is about 0.28 higher or 0.28 lower than the Demori company. Company Demori is about 0.28 higher in its average chocolate rating. So you would tell me what? Does that make sense to you? What does that tell you about the chocolate at Demori versus Caribbeans? What does it tell you? It tells you, so just think if I say Demori got an average chocolate rating that's about 0.28 higher than Caribbean, see how I'm taking the difference? What does that tell you? Demori is better chocolate. Yeah, so you're like, oh, they're higher. This is a number, right? This is an amount. Like they're this much better. So it's not group 1, group 2. When numbers are used for groups, it'd be something like, what state are you born in? And so if I said, oh, I'm born in Tennessee, Tennessee is state 40, and you're born in New York is state 30, does our difference in 10 make a difference right here? Or what about if I use our phone number to say, my phone number is 1,000 more than yours? Does the difference in phone number make sense logically? Like if I say my phone number is 1,000 more than yours, or I use, no, it doesn't, right? Or if I say my classroom's in 218, your classroom's in 219, your classroom's 1 more than mine. You'd be like, well, the number's 1 higher, but it's just kind of a room we meet in. It's not an amount of classroom. This is like, how much was their average chocolate rating? What type of variable best describes player ID? Player ID? Ooh. Anyone got a guess for player ID? Well, but also it's player ID. Can anyone help out Ava right there? We're doing a lot of help right here. Can anyone help out? Well, but it's a special kind of categorical because can player ID repeat? Can player ID repeat? Well, but can player ID repeat? If I say your player this, your player this, your player this, can player ID repeat? Can you get where I'm going with that? It can't repeat, so it's a special kind of categorical. And special kind of categoricals, Evan sees it right there, are identifiers. Does that make sense? So if you get a categorical variable and it can never ever repeat no matter what, so it would be an identifier. It'd identify which player. So think about that. Player ID identifies which player you're talking about. If you say I'm talking about player 4851 or something, there can only be one player 4851. Great job, Ava, right there. Thank you for asking. Does everyone see the small little things to notice? Like an identifier is a categorical variable that cannot repeat. Quantitative variables are actual real numbers. So a blank is a group of people or items that we want to understand. So what is the people or items we want to understand? Now put these on your note cards. These are good definitions. The blank is a group of people or things we want to understand. The sample is our view into a population. So Corbin got it right there. Evan, good guess right there. And Corbin, good answer. Don't worry, we're here to practice. The sample is our view into a population. The population is the thing we want to understand. The sample is what we take to understand a population. So we say, I want to understand this population. Like maybe you want to understand UT students. So the thing you want to understand is going to be your population. Can you give an idea of a sample? So we go out and we take 100 UT students. So a sample is a subset of your population. It's not what you want to understand. Like you get knowledge from your sample, but you don't want to understand your sample. The reason you try to understand your sample is to what? The reason you understand your sample is to do what? Like imagine your mom says, I'm going to make cookies for you for your big bake sale at UT. We're doing a big bake sale at UT. And she says, I want you to sample some of my cookies. She gives you different cookies right here. Now, when you try these cookies, the green, the blue, and the black cookie right here, the black and white cookie, Seinfeld reference. So when you try these cookies right here, are you trying to just understand the one cookie you're eating right here? Or are you trying to understand like how will the cookies be? Burned cookie. Now it's got some chocolate on it. So when you try these cookies right here, you're not trying to just understand these one cookies. Like your cookie that you try is your insight into how would these cookies be in general. Does that make sense? So you're trying to generalize from taking one of these cookies from each group. That's your sample from each group of these cookies. So you're sampling 3 different cookies, and then you're trying to understand which cookie would be the best to bring. So you're trying to understand the population of green cookies, the population of blue cookies. And so you might say, well, maybe I need to try a few cookies, Mom. Maybe I need to try because there's variation within the cookies. So you might say to your mom, got like a cut there. You might say to your mom, I need 3 cookies from each group. I need 3 cookies. She says, okay, you're doing good statistics here. So does that make sense right there to the question, like what is a sample? The sample is the things we take to make inferences from onto the population. So we're going to take 3 different cookies and try to make inferences onto the population. We got some more time. We got to 11:20. And the last other words right here are statistic. Statistic is what we learn from a sample. Samples give us statistics. And then we also have parameter because we're trying to understand the truth about how good the cookies are. That's the parameter of interest. The group would be all cookies. The sample is the cookies we eat. And our statistic is how good we think the cookies we eat are. Let me repeat this. In this cookie example right here, the sample are the cookies our mom lets us try. The statistic is how good we think the cookies we tried are. The population is all cookies we will bring to the bake sale because we want to understand like this whole idea that we won't be able to try with our sample. So we're going to make ideas or understandings about the larger group from our sample. And then the parameter is kind of the statistic, but for the population, which is the truth for how good all the cookies are. So we take a sample of cookies, we try how good they are to understand how good all the cookies are. So this is all the cookies and how good all the cookies are. Does that make sense right here? We talked through the cookie example right here with we try 9 different cookies from our mom. We tell our mom how good those 9 cookies are to understand all the cookies and how good all the cookies are. I'll repeat it one more time. We try 9 different cookies and learn how good those 9 cookies are. This is how good they are. To find out how good all the cookies are, and this is how good all the cookies are. The number 5 question for the first version that we did was wrong. Was it? Was it? Let me see. The type of data represents real numbers. What was the question again? compute the median of the small. It should be the median is not influenced by outliers. We said true right there, right? Evan, what was the question? Was it the median is... Yours might have been a little different. Yours might have said something is... The median is not influenced by outliers. The mean is highly influenced by... Is that true or false, Evan, right? Yours is different, though. Mine said median, right? Mine did say median, right? Let me see the video. Yours might be different. I'm going to double check. Where's the video? Officers. Okay, 2 seconds there. I got to know. Because there's variance on these questions. 100. Real number. Quite highly influenced by outliers. Yeah. So yours might say mean. I just didn't know. Evan, don't worry. 100 points. You get multiple attempts. Yep. So you have to be careful, and that's good practice for the test. Good practice right there, Evan. The median is highly influenced by outliers. That is false. The mean is highly influenced by outliers. That is true. So be very careful right there. Evan, thank you for mentioning that. I do make mistakes. Can you explain why that is? So numerically speaking, if we have numbers here like 1 and then 4. Oh my God, color change pen. 1, 4, and thinking of 3 numbers to divide by 10. What is the median of that number? What is the median of this number? So what is the median here? So tell me what the median is. So just look at the 3 numbers. It's 4. Great job, A, right there. The median is 4. What is the mean? So what is the mean of these numbers? So now I actually want you to find the mean of these numbers. So you're going to have to find the mean. I made it a little bit easy, but think about, because some questions do ask you to find the mean. So what would be the mean of these numbers? It would be 5 because it adds up to 15. And great job, Victoria, right there. Good practice. The mean is 5. So add all the numbers. They add to 15. Then divide by 3 because there's 3 numbers and you get 5. Now let's change the numbers and add in a bigger outlier. 1, 4, 145. So what is the median of these numbers here? What is the median number right here? What is the median number? So, be careful. Wait, people are saying 50. Careful, the median number. I might have not articulated well enough or spoke well enough. The median is 4, but the mean is 50 now. So which of these is highly influenced by outliers? So the median is always the middle number, and outliers are extreme values on far sides of the distribution. So with this right here, we can see in this small example that the median did not change and the mean did. So the mean will be pulled in the direction of outliers where the median will not be. So good questions right there, Evan. Hopefully that's making more sense right there and showing how the mean is influenced by outliers, but the median is not. Little small examples like that, trying to write them out is good practice. Now these numbers are in order, so the median is just the middle number. Don't forget to put the numbers in order. The median did not change. It was not influenced by the outliers. Exactly. The median is not influenced by outliers. The mean is. The mean is. And if I say it wrong, let me know. Which of the following is a univariate display of quantitative data? So we have graphics on here we really haven't talked about much, so don't choose those. The only one we really haven't gotten into much detail on is a scatter plot, which is bivariate quantitative. Mosaic plots are bivariate categorical. And histogram right there, Victoria, you got it. Great job. So good practice right here. Hopefully we got a 10 out of 10. Oh, wait, we did miss something. What did we miss? Wait. No. Oh, wait. Oh my God, I said it. No, this is Brian selecting the wrong answer. So but I did say it. Please review the tape. I said population about 20 times. It's population, and then for some reason I selected parameter. I thought it was telling me parameter was the right answer, and I thought we had a wrong answer in here, but it is population. So I do make errors too, but don't worry, I could retake it. I can always retake it, but check out the tape if you want. You're hurting your GPA. Evan, 100 points are there. I like that. Man, I'm just destroying my GPA. See, Evan, I think you knew I was going to miss one. You were having this like psychic sense going off in your brain, telling me Brian had missed something, and it was just for that question right there. It was a future psychic sense. It wasn't past. You gotta make sense of these premonitions you got. So let's head over here. We're gonna do a little more work. Great job, everybody. Don't miss questions. Don't be like Brian. We got question quiz, chapter 3 quiz, question 2. Let's go check it out. Great work. Who got those 10 out of 10s on the Canvas content? Now write down those questions. Write down the questions I got. But who got some 10 out of 10s on Canvas content? Any 10 out of 10s in the chat? If you're a 10 out of 10 on the Canvas content, let us know. Victoria and Ava right there. Great job. Get those 10 out of 10s. Show up. We'll do your questions that you have. If you're watching this in the future, great job, Meredith and everybody, and James. If you're watching this in the future or you're stuck on any Canvas contents, just come in here. We'll work a few versions. We can kind of answer your questions a little bit. Oh, and then someone says the quiz question, but I need to know which one. Anytime you mention a quiz question, I have to know which one because your quiz questions change. We'll probably have to come back to this. Someone said, I should have told them, chapter 3 quiz question 2, but I'll need you to expand upon it. Mean is the bane of me. Evan, you got 2 attempts. Use those 2 attempts right there. So I went over it and I still got the exact same one wrong because I'm special. Oh no, no worries. Me is the, but write it down for the test, Evan. Write it down for the test. Write it down. So remember that. You got this. An organization provides data on smoking rates by year and for men and women separately. A table is written. You got it. There you go. Evan, good job. That way when you get to the test, you get it right. Engraving it on my hand. Say you can't. What if it's a tattoo? The median, like what if you tattoo every question to yourself? And then teachers are like, well, that's cheating. You're like, well, I'm gonna have it with me at all times. I mean, is it cheating if like you have it with you? I mean, what if you got the periodic table of elements tattooed on your arm? During a test, could a teacher say you can't look at your arm? You'd be like, I literally have it right here. I have the periodic table. And they say, well, you can't look at it. So well, it's always going to be with me. I wonder how that would go. Like you went to the college, you're like, look, I love it so much that I have it here as a reference because it's that important to me. You say your dedication is very important. I'm going to find this question. An organization. I don't know. How small would the tattoos be in order to put them all on your arm? You could just get some big muscles. You get big muscle and so step 1, get swole. Step 2, get tattoo. I have not passed step 1 yet. An organization provides, okay. Complete parts A through B. Sounds like a goal. Get swole. There's some hashtag life goals right there. Let's do this. Okay, we're having some fun right here. Smoking rates. Okay. And this is, here we go. Cool. Let's do it. Life goals, hashtag life goals. We've got a table right here, so it's bivariate, it sounds like to me. Yep. Okay. We got, wow, this is a multivariate. There's 3 variables involved right here. We've got what year is it, and year, they're using it like as a grouping variable. We got the group right here. We got men, we got women. There's a lot of info on the screen, a lot of info. So this is actually a trivariate display because you have a year, you have age group, and then you have men and women. So it's actually 3 variables. This is a 3 variable contingency table. Someone asked about that in class, didn't they? Shout out to in-class person asking about that. It's rare that we see something like that. Compare the smoking rates 18 to 24 old women to that of men during that time period covered in the table. Okay, so we need to go here. We're going to highlight as we talk. It says compare the rate of women to men. It looks lower from what I can see. And over the time period, let me see the question again. To that of men during the time covered in the table. So men right here are going down. So men start at 42.1 and then go downward like this. Women also decrease but have a different starting point. And the women still go a little bit lower. So the women are always a little bit lower. Wait, why is there 3 variables? Variable 1 is age, variable 2 is year, and variable 3 is gender. So there's 3 variables. Gender. So you have gender, year, and you have age. Does that make sense, Evan, right there? There's 3 variables, gender, year, and age. Looks like they both have a downward pattern over their years. Men start out a little bit higher. The trends are in the same direction. The rates for women are generally lower than the rates for men. Relatively fewer men. Okay, relatively fewer women over the age of 65 smoke. What other variable might affect this? Oof. Speculation questions. Okay, so relatively, let me look at it again. Relatively fewer women over the age of 65 smoke. The overall smoking rate of the population, whether or not a woman has children, the smoking rate for women of all age groups. Ugh. Oof. This is ugh. Well, we're gonna find out the right answer to it because I'm not liking that question. First one's easy. First one's just numbers. Any sort of speculation question on my Pearson's a little bit mean. Not a fan of their let's speculate. All right, so they're talking about this right here. So they're talking about that. Let's see. Let's eliminate some answers. Relatively few women over the age 65 smoke. What other variables? So they want another variable. Having children is a variable. The smoking rate for women of all ages. The number of women in the population. That sounds wrong to me. The overall smoking rate of the population. So it's either going to be one of these right here. This is such a weird speculation question. Women also smoke less than men. That might be what they're getting at. Like, they're either wanting you to speculate outside the bounds of the question and come up with a lurking variable, which they don't even call it that. Is the children. Oh my God, James. Thank you, James. Yeah. I agree. James, that's worth 1,000 points. Thank you for just jumping in here. I do think that's a mean question. If you got, every once in a while you'll hear me say this, if you got this one wrong on your quiz, email me and I'll fix it. So if you got that one wrong right there, I'll say it on certain questions. Email me and we'll change it. But it has to be like this. It can't be the top one. The top one's pretty obvious if you look at the numbers. Speculation questions are things I'm not a huge fan of. But when they say other variable, it seems to me they're talking like outside of the current variables analyzed. So like what's another variable that we didn't take into account right here? What did Ava say? No. It's just that this pulls from such a large bank of questions that sometimes one of the parts of the questions is a little like speculative, and I'm not a huge fan of it. On the test, we're very careful about what we put on the test. Not that we're not careful about these, but these are a little more like, the best thing. How do you know what the test is going to look like? What's your best way to know what the test is going to look like? Do we have 15 minutes till class? I need to send out the class email. What is your best way to know what the test is going to look like? Oh, we can send out the 15 minutes till class announcements. And let's see, we got to do a little bit. 15 minutes till class. We might have to start class in 15 minutes. Be early for bonus. Tell people, lots of bonus during office hours. Thank you everyone for being here. We might actually need to do 3:20 at the start of the next office hours because I might end this stream right here in a moment. Can you do question 4 on the quiz? On this quiz right here, we might end with that and then we'll come back. But what's the question say, Evan? So what does your question say on the quiz, Evan? Let me know what it says. Keith knows what's up right there. A research group asked U.S. adults 20. You see, I got all the questions. Let's end with that one. Then we're going to start. Is it this one right here? We did this one to start. So we might end here in a moment. So this one, is it a little different? Oh my gosh. You think so? No, but this one's a bit different. So let's finish it off. But I will rewatch Officers. Awesome. Yeah. Then we'll make sure to record right here for you, Evan. We've got it. Or John. Sorry, John. I've got it listed right here for the next start of the office hours. I'm going to put it right here, and then we'll start BAS 320 on that on the start next office hours. We'll end off with this question here, Evan. We'll try to do it a little quickly, but we're going to try to throw in this video, and then I'm going to grab more coffee. Stat 201, Chapter 3 quiz, and this is a research group. Yeah, thank you, and great job, Meath and everyone. Thank you so much for being here. So we will do it next office hours. You got it. A research group asked, so this is a table of people's ratings of, I think, job performance or something. Thank you, John. So kind to me. And we have U.S. adults, we have presidents. So we have two groups. We have how do you rate the performance and what group do you ascribe to? But different sub-question. It might be the first one we did, Victoria. We did a version of this to start at the very start of office hours here at the 7-minute mark, which was a different end to it. So that's why I thought we had done this, but it looks a little different. So I'm doing the different version here to end. Circling back. What percent of college presidents think that the higher education provides a very poor value? Ooh. So we're saying of the college presidents. So we need to look at only college presidents right here. There's only 1,037 college presidents. So 31 of that group. So this is a conditional distribution right here. And we're going to round it up. So 2.9, that rounds up total to 3%. Where's my round button in R? That should round up to 3%, right? You know what I'm going to do? I'm going to cheat. I'm going to go here to R. Round right here. No rounding. Where's my number? Take this number. Round right here to 2 decimals. It rounds to 3. Okay, we're good on that. Nice job, Victoria. So that's got that. What percent of U.S. adults think that the provided is either good or excellent? What is comparable percentage of college presidents? Oh my gosh. So either good or excellent. So now we have to put the good or excellent together into one group. So about blank percent of U.S. adults. So we have to add together these amounts for U.S. adults. So 749 plus 113, that's for U.S. adults. And then we divide that by 2164. And then we round to 1 decimal. Make sure to round. I will give you your points back if you don't round properly, as long as you don't round crazily. There's a bunch of instances where I'll say like, yeah, it's fine. I want you to get the points if you did it. Now we're combining U.S. presidents. I'm going to highlight. Wow. Let me highlight here. We're doing U.S. presidents out of the total or college presidents. So what they're trying to show is the college presidents have a different view. They're trying to show that conditionally, got to make sure you add up the numbers right. And 76.2. Yeah. So they're trying to show that. They're trying to show that college presidents think it's a way better value. Compare the distribution of opinions. On average, college presidents have a better opinion about the value of the college system. I mean, they're college presidents for a reason. Is it reasonable to conclude that 5.22% of all U.S. adults think that higher education system will provide an excellent value? It's just our sample. So 113 divided by... No, the sample is probably not representative of the population of U.S. adults, so the true value, no, is much larger. You can't say it is much larger, it's just that it's an estimate. The sample is likely representative of the population, so the true value may be close to, but not exactly, because this is only one estimate. That sounds pretty accurate. The percent 5.2 is significantly different from the percent in the sample. No. The sample is representative of the population of U.S. adults, therefore exactly, no. It's not exactly, it's an estimate. So that's a really good end to the question right there. I do like those final answers right there. It really says how 5.22 should be interpreted. The sample, if it is representative, the true value may be close to this, but not exactly. You're welcome, Evan. Good question right there. Just some good calculation numbers. And then at the end, this is what a sample is. We went out and talked to a group of people, and then we're trying to make estimates about all U.S. adults. So the truth might be close to about 5.22%. Thank you, Keith, right there. That's the goal. Just ask for whatever you need help on, and we'll just keep working away. We do as many questions as we can get through. And we'll be doing class here in just a little bit. Tell people in class, be like, swing by office hours, ask those questions. We did a good bit today. We did Canvas content. We did a few questions on the assignment. We did some 474. And we'll see everyone in class here soon. Bye for now. Bye.